In today's video, I'm going to review these bus bars, and these are made by a company called Tech, and they have several different models available. The model I bought is rated at 150 amps, and they have 6 terminals, and then I chose the 1/4 inch terminals. They also make some bigger ones at 5/16, but I wanted a slightly smaller one for my particular application due to the lug sizes that I was going to be using. All right, let's go through the specifications one by one. For one thing, it comes in a 2-pack, and you have them colored, one black and one red, which is awesome because you can easily identify your positive and negative. They come with 4 mounting screws and 2 plastic covers to prevent accidental shorts. Now from this image it says that the bar is copper. I cannot verify that because it looks like it is another metal, but maybe it's copper with a zinc plated coating. I do not know, but they claim that it's copper. Now the stainless steel nuts and bolts are included, and that's great for an anti-corrosion protection. And then you have a nylon mounting surface and a polycarbonate cover. And then the insulating boots there are rubber boots. Now, as I mentioned, the one I bought is rated at 150 amps DC current, 130 amps AC, 48 volts DC, or up to 300 volts AC. So for a 12 volt application and a moderately sized inverter, these work great. The one I bought is 6 1/4 inches long, which is about 150 millimeters. It stands roughly 31.5 millimeters high, and it's approximately 19 millimeters wide. Now the price I paid at the time of this recording was $24, and I think that is a decent price, but roughly $12 per bar. So that's a pretty good deal. Now these are particularly useful in RV applications where you have maybe a 12 volt system where you want to add some components to it, like an inverter, or you want to run some more circuits somewhere else. And so the issue comes in with the battery terminal. You start running out of room to put all your connections at the battery terminal. They start stacking up and it becomes a problem. And so what I did was I created some temporary bus bars in my motorhome, which I will show you, that were sort of similar to this. I used some steel I got at the hardware store, and they worked okay for my temporary application, but I wanted to get some better ones that were designed with some features that I really wanted. And so one of those features is that you don't need to put a wrench on the back side of any one of these terminals in order to tighten this down. On my temporary terminals that I made, I put bolts through, and then you had to tighten them from the back side, and this proved to be problematic in the real world application. So what happened was I took a wrench to it, I tightened it down, I thought everything was fine, and then I went to connect it up and I had 1 volt. Why? Because one of the connections had come loose and it was not tight. So I decided to go ahead and buy some better ones. And so these have some slight grip to the back side, and that can kind of dig in a little bit to the connection, and they are completely insulated from whatever surface that you're going to attach to. Theoretically, you could mount this to a metal surface because they have a plastic insulator protecting this from the screws that would go into the surface that you're mounting to. Now, for my application, I'm going into wood, but that's an added feature that I wanted out of one that was more commercially available. And the second thing that I really liked was the fact that they have these connectors. So if you have a bus bar and you have them, say, close together in a cabinet or something, and you don't have this connection over, if you ever something hit it like this with a metal bar, sparks are going to fly. Hopefully you have a fuse connected because you're doing a direct short on the battery, and that is not advisable. So the way this works is cool. You still have complete access, even with heavy cables right here, that you can access any one of the terminals, except for, I guess, the last one that's a little bit harder to get to. But at least these 4 right here have got some pretty big slots on them, And then that protects from an accidental short this way, and yet you still have access in order to mount them. So now let's take a look at some of the ratings here. So we can see we've got 6 possible connections in the one that I bought, and the bus bar itself in this particular model is rated to 150 amps. And so for the application that I'm using in my motorhome, I don't think I'm going to go much over 150 for the inverter that I intend to use. I'm not a big fan of like 3,000 watt inverters on a 12 volt system because the currents just get out of control. So I have 2 100 amp hour batteries that have a total capacity of 200 amps, but I don't really foresee using the full 200, and I think 150 will be just right. So we could do the calcs, 150 times say 12.5. That is going to be probably around 1800 watts or something like that. Let me take a look. I'll put that number down exactly. I just can't quite do it in my head. So I'm going to go out to the motorhome and go ahead and install them. You really won't be able to see me install them because I'm in this cabinet. But you just got the 4 screws that come with it, and you just mount it someplace that is going to work. So I'll go ahead and get that done, and then we'll hook them up. So here you can see on the back wall, these are the temporary bus bars that I created. I marked one positive, one negative, and they have a lot to be desired because you've got exposed terminals, and like I said, I had trouble tightening. It turned out that one of this wire right here was not, no, it was this one, sorry. This one going to the solar input was not quite tight, and it was showing just 1 volt, and that's because this bolt had come loose on the back side. So I don't recommend this. I'm just showing you this because I needed something temporary, at least to get this hooked up. So I'm going to take those off, and we'll put our new bus bars in, and then we'll give it a shot. All right, now we're done. I've taken out the old ones that I had on there for temporary, and I've got my plastic covers in place, and it's all securely mounted. And as you can see, even with the very heavy connections, there's still room to connect them individually. So I put a minor accessory on the right, and then I left that spot open on both the positive and negative here because I'm going to put an inverter right there. A very high current 2000 watt inverter, and I want them as close as possible to the connections going to the battery. So now you still have some exposed metal, and so you could wrap these with electrical tape in order to prevent a potential cross short, but the main terminals now are covered with these plastic things, and I really like those a lot. Now the only complication I ran into is that I brought out my SAE tools, and it turns out that you need a 10 millimeter to connect to the nuts on there. And I was kind of surprised that it would only accept a 10, and so that's okay, not a big deal. But there they are. So now the thing to do is I'm going to connect my inverter up, and we'll do a test here to make sure everything works properly. But now that I have 1 per connection, now I'm not going to get into a situation where I'm trying to double up and whatnot, and then each individual power source has its individual nut, and it's a lot easier to troubleshoot issues with that. So far so good. I really like them. So here I went ahead and did a test. I'm plugged up to the utility power, and I'm charging in at just under 500 watts, so about 36 amps. And I've got my oscilloscope here hooked up. You can see a little bit of ripple voltage, and everything's connected, and they are all just cool as a cucumber, and everything is working properly at least 37 amps. So we'll kind of ease my way up here and see if we can do 100 amps here on an inverter and see how it goes. All right, here's my heater, and I know that on the first one we're at about just under 1,000 watts. So I'll go ahead and turn that on. I've got the inverter plugged in here and connected. And then you can see on the oscilloscope when I turn this on, we're going to get some ripple voltage. So there, that's 1,000 watts. And our voltage is dropping down to 13.1. So this inverter can only handle it for about 2 minutes. But testing, putting my finger on the connections, so we've got a good 90 amps going through there and everything is working great. So I do have another inverter I can test that is rated at 2,000 watts. This is a modified sine wave, so it's basically a step inverter. So I'm going to have to shut this off or this is going to go into overload, the inverter will. But anyway, it is working fine. So shut this off. Let that cool down so we don't get into overload. And then you can see from the oscilloscope that we have a lot less voltage ripple. So anyway, we did a good load test. It charges fine, it takes a load fine. Sorry about the lighting. And I'm very happy with it so far. I wish I would have bought it sooner. So anyway, I'll put product links in the description below. And then that's it for today. I'll see you next time.